So today we're going to talk about the atomic radius. Yes, folks, that means we're talking about the pant sizes for atoms. We're going to relate that, the atomic radius or the atomic size, to those periodic trends that we started yesterday. And then we're going to talk about shielding. So, Unit 5, periodic trends. Atomic size! So, an atom does not have a fixed radius. But scientists found, by measuring the distance between the nuclei of two touching atoms, and then they half that distance. So, what does that mean? We have to look at a picture because I don't read a book unless there's pictures in it. The actual atomic radius is half of the distance between the nuclei of two like atoms. So, half the distance between here, and that is the radius. So, let's put that into trends. When you go down the periodic table, top to bottom, we call that a group on the periodic table. The atomic size will increase. And that makes sense, right? Because we talked about energy levels, and they increase as we go down the periodic table, right? And each energy level adds another area where electrons can hang out, can chill, can be like, yo, what's up? So that means they're increasing in size. So what's the other way? Going from left to right, following the periods in the periodic table, the atomic size decreases. So why? Why do they do that? Elements have the same number of occupied energy levels. Well, yeah, they're on the same period, but a greater number of protons. So what do protons do? They add charge, which means as you go from left to right in the periodic table, you are increasing that charge. So let's look at the beautiful periodic table. Look at period number 2, or energy level 2. We start off with lithium. That's at 3 atomic number, which means 3 protons. And if you go to the left all the way to neon, so it's lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Neon's at 10. So that is increasing the number of protons, which is decreasing the size. So protons don't decrease the size, they just increase the charge. And that positive charge is going to grab onto those negative electrons whizzing around doing their own thing and pull them together, meaning a tighter atom or smaller size. So with that in mind, let's talk about the shielding effect. As you go down the periodic table, meaning increasing energy levels, 1, 2, 3, 4, 5, 6, 7, the atomic size is less pronounced due to the shielding effect. So what's the shielding effect? The inner electrons are being shielded by the outer electrons because the inner electrons are closer to the nucleus, closer to that positive proton charge. So the outer electrons are more free to do what they like, which of course we already know that the outermost energy level where the electrons hang out is actually where chemical reactions happen. That's where chemistry happens. So put it in the terms on the screen. The inner electrons shield or block the attraction from the nucleus. So there's still an increase in size of the atom for the lower periods, but it's less significant because those inner energy levels are being shielded. So let's look at potassium. Potassium's on period 4, energy level 4. Let's compare it to lithium, energy level 2. So if I am potassium, my second energy level is being shielded by the third and fourth energy levels. So my number 19 atomic number electron of potassium is actually whizzing around, not getting too much pull from the central nucleus where the protons are, because that nucleus has to go through the second energy level, a third energy level, etc. And that's what the shielding effect is. So look at this beautiful picture. This is the atomic size of some of the elements of the periodic table. Here's cesium, which is the largest on this image. Of course, below cesium, if you're looking at your periodic table, is francium. That is larger because it it went down the periodic table, which means it's increasing in size. So cesium is the largest here. And we can look at all the other ones, and we can tell from going left to right, the atomic size gets smaller. But the smallest on the periodic table is helium. And we already know that helium is actually found in the s orbital, but it hangs out over, sitting above the p section on the periodic table because it's a noble gas. But here is another reason why helium hangs out where it does in the periodic table, because it has a smaller radius. So it hangs out over there because it's a noble gas, and now it needs to be the furthest away from hydrogen because of its atomic radius size. It's smaller. So summary. How can we remember atomic size on the periodic table? The periodic trend of atomic size. The snowman. So this is like this really angry dude sitting here. Someone stole his Honey Nut Cheerios that morning for breakfast, and he's ticked. So he's going to walk around the neighborhood, and whenever he sees a snowman, he's going to karate chop him in the gut, and that snowman falls over. Someone kicked down my snowman. So this is a perfect way to remember atomic size. The top of the periodic table increases as you go down, and from left to right in the periodic table decreases as you go left to right. So big, medium, small. Good way to remember it. Go ahead and start the worksheet.